Hello friends, this question is from the subjects of network in the topic of transient steady state analysis. It's a common data question of 4 marks in which one circuit has been given, and in the first question we need to find out the voltage across Vt or voltage Vt at t is equal to 0 plus. First of all, there is one correction. In the circuit, instead of the 22 ohm we have a resistor of 2 ohm actually. It's just 2 ohm that has been printed as a 22 ohm. It's a correction. So now we need to find out the voltage across this 2 ohm resistor, which is named as a Vt at t is equal to 0 plus. So we know that a circuit has said like that the knob T is connected to the point A, and circuit is in steady state. At t is equal to 0, we have we have changed the knob from position A to position B. So uh, before this change has been occurred, my circuit is in steady state, and we know that the capacitor opposes the sudden change of voltage. So let's draw the circuit, a steady state circuit at t is equal to 0 minus. At t is equal to 0 minus, I'm going to draw the steady state diagram of the circuit. So the steady state diagram of the circuit will be, we will have a battery of 5 volt. Right, in this case my knob has been connected to the point A. Here my capacitor C will be charged and will behave like open circuit, and I will have a resistor of 2 ohm across which I need to find out the voltage Vt. So my capacitor has been connected to the supply 5 volt, and it is open circuited because it will be charged to the supply voltage. So if I may find out the Vc0 minus, my Vc0 minus will be equal to the 5 volt. It will be charged to the supply volt because we know that my circuit is in steady state. In steady state, the capacitor will attain the maximum possible voltage which could be charged. In this case, it is 5 volt. Now I know that my Vc0 minus is 5 volt. Now again I will draw the circuit for at t is equal to 0 plus. Now at t is equal to 0 plus, I am going to draw the diagram. At t is equal to 0 plus, what change has been occurred? My knob T is shifted from position A to position B. So at t is equal to 0 plus, I will have this RC loop because my battery will be disconnected from the circuit, because battery is a part of the knob A, but now my circuit is connected to the knob B. So at t is equal to 0 plus, my effective circuit will be resistor 2 ohm resistor with a capacitor. We know that capacitor opposes the sudden change of voltage. So my Vc0 plus must be equal to the Vc0 minus, which we have just calculated, is equal to the 5 volt. It means that my capacitor will behave like a battery of 5 volt. And friends, here let's see the polarity of the battery. This terminal of the battery is connected to the positive terminal, so that we have a positive sign at this side and negative sign at this side. And we know that when we make a change, the capacitor always retain the polarity of it. So it means that the positive terminal of the capacitor will behave like a positive terminal, and the negative terminal of the capacitor will behave like a negative terminal. So the positive terminal of the capacitor will now behave like a positive terminal of the battery, because it will behave like a 5 volt battery. This is the important point. So now we can draw a 5 volt battery here and a resistive network. So this is my resistive network. So what will be the current? Or you can see like this, that it's a 5 volt battery and we have a 2 ohm resistor, and we need to find out the resistor across this 2 ohm, which is termed as a Vt. So if I can apply voltage divider here. So if I may apply the voltage divider, my Vt will be equal to the 5 into voltage across the resistor, across which you need to find out the voltage upon total resistor, which is 2 plus 2, 4. So 5 into 2 by 4, it is equal to 2.5 volt. So my Vt at t is equal to 0 plus, my Vt is 2.5 volt. So here 2.5 volt in magnitude, but you need to see that the Vt has been defined as plus and minus. You can see that the polarity of the 5 volt battery is like this. The current always flows from high potential to lower potential. So if you may draw the direction of the current, it will be like this. So my direction of the current is opposite to the direction of the polarity of the Vt. We will have a minus sign. So the effective voltage of Vt will be minus 2.5 because you are sampling the Vt with in an opposite direction. Because my current is flowing from minus to plus. So that's why instead of 2.5 volt we are getting minus 2.5 volt. So in this case my correct option is option B. For the first question my correct option is option B.